part which I want to cover is, you have seen over here, when I open this driver, when I open this driver, I perform a open, and when I perform a read, it's giving me 0 bytes. It's not giving any data to me. Okay, so how do I basically send the data to the user space? After all, my driver is something which can give me the data and which can take my data. So I want to enhance this driver and to do that. From the user space, read looks like this. Okay, and if we compare this read over here, file descriptor corresponds to the file structure. Buffer in the user space corresponds to the buffer over here. Count corresponds to the length over here. That means there is a one-on-one mapping if you ask me. File descriptor, file structure, buffer, buffer, count, length. That means whatever you send it from the user space, you are receiving it over here. Of course, internally those things, file structure and all have been changed. You have got a different value, but after all, it's like a callback handler. Okay, it's basically in this application's context, you are invoking this particular uh, function. And L of t, let's not speak about that. Let's keep it aside for time being. But overall, these three arguments are matching as is. Okay. Now, if I want to send any data given a pointer, you see it is saying like underscore underscore user. It says it's a user space pointer. That means whatever you are sending it from here. Now I have written the application. When I invoke a read over here, there's something called data. There's something called data, right? That is the variable, and that is actually our buffer. We have declared the buffer for this. Yes, 128 bytes buffer. So I'm getting a pointer to this 128 byte buffer over here in my driver. Okay. So if I get something like this, that means I should be able to use over here memcpy. Okay, if I have the read buffer, what I can do, memcpy destination is buffer, source, let's say I will put it hello, 5 bytes. Okay, I should be able to do something like this. Does it make sense? Like it's an invocation, it's a callback handler. You are being provided with a buffer. You basically write into that buffer. You have got a pointer. So will this work? Now, one thing which I would like to make very clear is, see, in the application space, when you are into the read, what do you expect? That the buffer will be populated by someone else. Okay, but when you are into the driver, it is you as a driver writer who needs to write into the buffer. So what I mean to say, when you invoke a read from application, you read from the buffer. When you are into the driver space, you right into the buffer. That's the perspective which you will have to change. Many of the times I've seen guys getting confused. Okay, read means reading from the buffer. No, as a driver writer, you're not the application writer. As a driver writer, you need to write into the buffer because you are the data provider. Application is a data receiver. And similarly, when it comes to write, you're not supposed to write into the buffer. You are supposed to read from the buffer. Okay, so that perspective changes over here. Now in a read, when I say application is expecting read, that means you are the data provider. You are going to read from the device right into the buffer. Okay, that's what you need to remember. Hope it is making sense to everyone.
Yes.
Okay, now, so now coming back to our point, basically we have got the mem copy, buffer, hello, and 5 when I do. So the question is, will it work or not? So of course, since this is a pointer, it has to work logically, right? So let's compile it. Okay, we'll compile it. So I'll just comment this out, and let me just clear this, and I will. So I got the null.ko. I've transferred this to the BeagleBone Black. I'll do the RM mode of previous null. I'll do the ins mode of a new null.ko. I've got the same major minor number right now, so I can do it with the same file. Okay, this thing. Now, what I will be doing, I will perform a read on this file slash dev xyz open to read 5 characters. When I try to do this, I get a crash. Okay, I am getting a crash. Okay, so yes, logically doing that is correct, but from the kernel perspective, it's not recommended to do that. You see what it is saying? Page domain fault. What do I mean by page domain fault? As you know, there is something called the user space, and then there is something called the kernel space. So this is a user space buffer, and this buffer you are trying to access. We are accessing user space domain buffer in kernel space, which is not recommended. So remember, I'm using the word not recommended. What do I mean by that is, if I want, by just changing one configuration parameter in the kernel, I can disable this stuff. And the same example, which is right now giving me a crash, will work fine. Okay, the same program which is crashing right now will work if I change one configuration option in the kernel configuration, where from the kernel I say, I know what I'm doing. I know what I'm doing. I want to access the user space buffer. Please don't prevent me. I want to access the user space buffer. Don't prevent me. Just one kernel configuration option, you change it, you will be able to use the user, because kernel is a boss. There is nothing which kernel can't access. Okay, so many of time when I ask this question, okay, you can do this, I get the answer. I get the all those options, like I get all those answers where they say this lies in the user space, this lies in the kernel space, this is kernel space table, this is user space table. I say, hold on, you are into the kernel space, you are the boss of the entire system. Who is there to restrict you? Nobody can restrict you. You can do it. Logically you can do it. The only thing is, I have enabled one safety option in my kernel which prevents me from accessing the user space buffer directly. That's it. No reason at all. You should be able to do it. Forget about kernel page tables, user space page table, all those fundamentals which you might have heard from somewhere. It's a C logic, normal C logic. You pass the pointer, you should be able to access the pointer. Kernel is the boss, he should be able to access it. But the thing is, you can access it, but it's not recommended to access it directly. It is not recommended to access it directly. So there is nobody who can prevent you in a kernel space from accessing anything in the user space, but it is not recommended. Why? The reason is for that is, as you know, over here when we did this stuff, my kernel crashed. Actually speaking, see, that's very dangerous. That means now I'm empowering my application to crash the kernel, right? Because this crash is in the kernel. This is a oops in the kernel which you have got. So that means somehow I am empowering my application to crash the kernel. That means if there is any malicious application which might be running, it can crash my kernel, which is a very bad thing. I want basically a security. It's not something like somebody comes, gives me some data, some random data, I'm crashing. So, from the security perspective, I would not like to do that. Another thing, let's forget about the security. What you will say is in a driver, I will perform my checks. I will do the proper validation checks. It's not null, it's valid, and all those things. But then also, there is one important thing in the user space. You might have heard about something like a swap out. Swap out. Whenever your system is low on memory, there are many applications running and the system is low on memory. To accommodate the space, what it does is many a times the buffer which is not dirty, okay, the buffer which is basic, which is not dirty, might have been swapped out. It might have been moved to the disk. This is what we call it as a swapping out. And now it might very well happen that application has provided you the correct pointer only. Okay, it has provided you something like uh, star p, which was a validated one, which was pointing to the buffer, like it has provided you the pointer to this buffer. But because your application was swapped out temporarily, it was not valid. It was not valid. And due to that reason, your kernel might crash. Now if you ask me, the chances of that happening is 1 in million. 1 in million. That means it would be million times your things will work fine. Just 1 in a million time, due to that heavy load and that instance when the buffer was swapped out, your driver crashed, your kernel crashed. Now just imagine how difficult it is to figure out this thing, because million times your application runs fine, once in a million it fails somewhere. So that kind of debugging is going to be very, very difficult. So what I would like to say is, you can access the buffer directly, the things will work million times, but there are chances of failure for that unfortunate case where your buffer has been swapped out. So now the question comes is, how do I access it? Fine, so I understand that that's where you have got the APIs by name copy to user, which does all the validations for you. Validations it will perform. It will basically check if that particular pointer is not valid, it's being swapped out. It will bring it back into the memory. It will request to the memory manager, okay, bring this back because I want to access it. So swap it in. All those things will be done by the call by name copy to user. So that's the reason we directly don't access the user space buffer. Instead, we access it using the copy to user API. And when we want to get anything from the user space, we use copy from user. Okay, copy to user, copy from user. So this particular driver, what we'll have to do is, instead of directly accessing it, I will have to do something like this: copy to user destination buffer, and what I need to pass, hello 5 bytes. Okay, and don't try to dereference anything directly. That means in the kernel space, you see this one, this attribute is to warn you. It's basically a warning sign to you. It's coming from the user space. Be careful. You might land you might land into trouble. So that's a warning. So never ever do something like this. Don't dereference anything which is coming from the user space directly. So this is the whole story behind this whole stuff. Okay, this is why we use copy to user, copy from user, not because the kernel page tables, user space page tables, all those junk things, just forget. It's a normal C program.